Welcome everyone to this astrophotography tutorial. My name is Marcos and I'm a photographer with a deep passion about astronomy and photography in the night sky. In this video, I will guide you through my full astrophotography workflow. Before we begin, it's important to understand how this tutorial is structured. Each level builds in the levels from the one before, so what we will cover in the level 1 will be essential for the levels 2 and 3. I won't repeat the same theory in each section. Instead, I will focus in introducing new techniques as we move up. That means if you are jumping into a higher level, you already need to be comfortable with the basics, like camera settings, focusing, and understanding light in the night sky, because I won't go all over again. So, we will begin with the fundamentals, understanding how the light behaves in the night sky, what gear do you need, and how to set up your camera to get the best results. Then we'll move to intermediate techniques, like stacking, calibration, and using software to enhance your images. Finally, we will dive into advanced topics, including deep sky imaging, telescope use, post-processing tools, Milky Way tracking, and much more. Alright, let's start with the first level. Perfect for beginners or anyone using a camera and a tripod. You don't need fancy equipment to start capturing beautiful night sky photos, just a bit of patience and the right techniques. First, let's talk about the gear that you will need. At this level, all you need is a DSLR or mirrorless camera with manual settings, a sturdy tripod, and ideally a wide-angle lens with a large aperture, something like f.2 or lower if possible. A remote shutter or an intervalometer also helps reducing camera shake, but it's not absolutely necessary. Now let's go over the basic camera settings for night photography. We will use manual mode. We will put the focus in manual too, zooming in the screen and try to focus the stars, making them as small as possible. The aperture will be as wide as your lens allows, f.2 for example. With the ISO, we will start with 1600 or even higher, like 3200. For shutter speed, we will use between 10 and 20 seconds, depending on your lens. Too long, and the stars will start to trail. A good rule is the 500 rule. What you need to do is divide 500 by your focal length to get the max shutter time. For example, with a 24mm, I do around 20 seconds exposures. For white balance, set it to manual. In Kelvin, use 4200, but you can adjust it later in post. Also, don't forget to use RAW mode. Once your camera is set, it's time to frame your shot. Look for a dark location away from city lights. Light pollution makes a big difference. If you want to find a dark place in the night sky, you can use the page Light Pollution Map. This page will show you where are the best places to shoot in the night. The most important thing is to try to avoid the moon, because the nights with moon, the bright of the sky is much higher, so you cannot get as much detail as a night without moon. You can use a mobile app like Stellarium to help locate interesting constellations or bright objects like the Milky Way, Orion, and much more. When you are ready, take a test shot and zoom in to check if the stars are sharp. Pay attention if your fixtures are still in focus when you are shooting, because sometimes, because of the temperature change on the night, the focus of the lens can change slightly and can unfocus your stars. We can start looking at basic editing to bring out the details. I have left all the links to the programs I'm using in the description, so you can download them for free and use them. For this level, we will go through a basic editing, using tools like Adobe Lightroom or Lightroom Mobile, a free alternative. The goal here is to enhance your photo without over-processing it. Remember, the better you shoot straight from the camera, the less that you will need to edit. First, we can adjust the exposure and contrast. You can bring up the exposure slightly in your photo if it's too dark. Then increase the contrast to help to separate the stars from the background. Carefully bring down the blacks to deepen the night sky and reduce haze, while lifting shadows a bit. Increase clarity or texture. A small boost in clarity or texture will help the stars to pop and add some depth to the image. ISO usually means some noise, so we will use noise reduction. Most editors have a noise reduction slider, but don't go too far because you will run out of details. Level 2. In this level, We will focus on improving the image quality by increasing the exposure time, because more time means more information and reduced noise. So we will use the tool stacking. We will also introduce the calibration frames, which help to correct common optical and sensor issues. These techniques will give you cleaner and better results, especially when photographing deep sky objects like nebula or galaxies. Stacking is the process of combining multiple images of the same object to reduce noise and boost the signal. In astrophotography, noise is a big problem because of long exposures and high ISO, but the stars stay in the same place, while the noise is random. By averaging many photos, the signal gets stronger and the noise fades. So, for that, you will need a series of photos that we will call exposures or lights of the same target, at least 20 shots. You can use an intervalometer and adjust the frame after each series of pictures as the sky moves. For this video I did this example, 500 lights of 1.6 seconds at f.2, ISO 20,000, 200mm focal length of the Andromeda's galaxy. Calibration frames. The calibration frames are special photos that help to correct flaws in your image. For calibration frames, we will use darks, pictures taken with the exact same settings as your lights, but with the lens cap on. They help to remove sensor noise and hot pixels. The noise on the sensor changes with the temperature, so it's important that we take the darks with the same temperature as the lights. I take them after shooting the lights on the same night. For this video I did 90 darks, but tried to take at least 1/4 as many dark frames as light frames. You will also need a stacking software. I use the free tool Deep Sky Stacker. I will process the data, align the frames, and calculate the noise with the darks. Follow these steps. First, press Open Picture File to load the lights and the darks into your Deep Sky Stacker. Press Register Checked Pictures. That will filter and detect the numbers of stars for aligning later. In advance, change the star detection threshold. Around 300 stars is enough. Align and start the images. The software will line up all your lights and darks and export a TIFF file with all the information. Once you have stacked your image, it's time to process it. And now we have much more data to work with. For that, I am using the free software Siril. First, go to Siril and open the stacked image. You will see a dark image. Don't worry, that's normal. You need to stretch it. But for now, you can display it in auto stretch mode. Crop the image with right mouse click and rotate and crop. Crop the image until the edges of the image are clean, without imperfections or artifacts caused by the stacking process. You can also do background extractions. I use it only when processing deep sky objects. This tool separates the object from the background, removing vignetting or gradients, and this will not work with white shots or Milky Way pictures. To see the gradients, press on Display Mode, Histogram. After that, switch from Normal to Rainbow Color Map. Go to Image Processing, Background Extraction. Press Generate and that will create a grid. I usually use the predefined adjustments, because they usually work the best. Then click Compute Background and finally click on Apply. Now you can switch back to Auto Stretch in Display Mode and Normal Colors. You will see that we have gained a lot of detail and information, and eliminated the vignette. Fourth step is Color Calibration. Go to Image Processing, Color Calibration, and then press in Color Calibration. Use a dark background reference for calibration, selecting it manually. Now press in Use Current Selection and Background Neutralization. To finish, we will stretch the picture. We will change to linear in display mode. I like doing first small stretching with the option Image Processing and Async Transformation, because it stretches the picture without desaturating the image. Play with these values and click Apply. This is a first stretch, so don't try to go too far. Finally, go to Image Processing, Histogram Transformation window and press in Apply Auto Stretch algorithm to the image. This picture will be probably overexposed, so you can adjust it by dragging the midpoint to darken and playing a little bit with the values. Now it's important that before exporting, you need to change the bit depth of the image to 16, because we will need it to do a final edit later. Press on the arrow and save the file as a TIFF document. Now you can take it to Lightroom again to do the final adjustments. In this part, you are no longer just photographing the night sky, you are processing data. It's a big step up, but it brings a massive improvement in your images. And finally, we go with level 3. In this part, I will just introduce some of the techniques that have allowed me to get the best results. We are going to focus in 3 main tools. We will use an equatorial mount for precise tracking, the Starnet tool to help to separate and remove the stars from your image, to edit them separately together with some Photoshop techniques, and the Mosaic method, which helps you to capture huge, high-resolution images from the night sky. Using an equatorial mount. If you want long exposures, more stars and better sharpness, an equatorial mount is all what you need. It works compensating the rotation of the Earth, avoiding stars from trailing even during long exposures, starting from 30 seconds or even much longer, depending on your alignment. That means you don't need any more high ISO settings, which helps to reduce noise and gives you much cleaner images. It's important to know that most cameras' maximum exposure time is 30 seconds, so to do longer exposures, you will need an external intervalometer. And now, the focal length is not an obstacle anymore, allowing you to shoot fainter objects with more detail. I have for this tutorial a telescope mount, which can hold more weight. It's more precise when tracking, but requires more calibration. You can also use a compact equatorial mount, being less precise, but also lighter and cheaper. To use the telescope mount, you will need to follow these steps. First, polar align your tripod base, so it points to the astronomical north. You can do it also finding the pole star. Try to do it as precise as possible, so we will do minimal adjustments later. Second, level your tripod base with a bubble lever or your phone. And that will be all if we had a compact equatorial mount. But in my case, I have to calibrate my telescope mount, a EQ5 Pro. If you don't have one, skip the rest of the steps. Okay, so the third step will be mount the telescope equatorial mount over the tripod and secure it with a lower vertical screw. That will also secure the tripod. Now you can plug the battery or the power source and then switch on the mount. You can look through the small viewfinder with both eyes open and find the pole star again. Once you find it, look at the sky and try to rotate the polar axis to put the constellation of Ursa Major and Cassiopeia in the viewfinder in the position of the sky on that moment of the night. Lastly, we will try to put the pole star into the small circle to finish the precise alignment. We will use the equatorial screw in the back to adjust the declination and the screws on the sides to pan the mount. Now it's time to mount all the gear that we will use. Before you start tracking or imaging, it's essential to balance your telescope. Your telescope will have counterweights, so it's balanced with the weight of the camera. In our telescope we have the right ascension or polar axis, and in perpendicular the declination axis. If you know how to balance a gimbal, this is similar. For balancing the right ascension axis, unlock the clutch or brakes so the axis can move freely. Rotate the mount so the counterweight bar is horizontal, parallel to the ground. Let it go gently, we're keeping a hand ready for safety. If the counterweight size drops, move the weight closer to the mount, and then adjust until the telescope stays horizontal, without swinging in either direction. Do the same with the declination axis, but this time moving back or forward the gear mounted until it's balanced. Now we need to plug in the hand controller and then switch on the mount. The controller will ask you for a few important details. The current date, time, your geographical coordinates and your time zone. When finished, press Start Alignment and align with 3 stars. You can use Stellarium to find 3 bright stars that are far from each other, so the alignment will be more precise. The best ones are Vega, Arturo and Altair in summer, and Sirius, Capella and Deneb in winter. The telescope will automatically see to where it thinks the star is, but due to slight alignment errors, it might not land exactly where it is. That's where you come in. You will need to manually correct this telescope position using the hand controller centering the star precisely in your camera or telescope view. You can also change the CU speed, pressing number 2 and then setting the speed that you want. Once you finish aligning the 3 stars, if you followed all the steps, the hand controller will display alignment successful. All you need to do is find the object you want to photograph, introduce it in the hand controller, and the mount will point automatically. Another big advantage is that you will need fewer individual photos to get good results. That makes the stacking process faster and more efficient. And the best part is once everything is aligned and tracked properly, the mount will keep following the stars on its own. While your camera captures a full series of exposures, you can actually relax. Now, we will go with the second tool. Mosaic method for higher resolution sky panels. If you want more detail, higher resolution, or to capture larger areas of the sky than your lens can handle, Mosaic is the best solution. A mosaic is made by taking overlapping pictures of adjacent parts of the region of the sky. Later, you will stitch them together to form a large resolution panorama of the night sky. First, plan your panels using tools like Stellarium. Always shoot with overlap. Around 50% overlap between frames will work when stitching. Use the stars to overlap. For 50% overlap, if one star is on the edge of the frame, on the next panel, reframe it until the star is on the middle. Always use the same settings and do the same number of pictures to avoid irregularities when stitching them together. One good thing is that you can use the same darks for all the panels. So, the workflow order will be: first, Lightroom lens corrections. Second, deep sky stacking of each panel. Third, stitch the panel with ICE. 4. Siril pre-processing. Do not extract the background. 5. Starnet star removal. And 6. Photoshop post-processing. One thing to take into account is if your lens have vignetting, when stitching, that will be visible as dark stripes. For that, I recommend importing all the lights and darks in Lightroom, and apply only a lens correction. In the lens correction window, remove the chromatic aberration and enable the profile correction. To stitch the panel together, we will use the software ICE, Image Composite Editor. Open ICE. Press in New Panorama from Images and open all the stacked panels in ICE. Go to the stitch window and the program will show you some projections of the stitch panel mosaic. I usually choose Mercator projection, but you can choose the most adequate for your shot. If you have some problems with the stitching, try to organize the pictures before, numerate them or rotate them if necessary. Finally, crop the picture as little as possible and export it as a TIFF file for later pre-processing in Siril. Removing stars with the Starnet. Once you have stacked your image, Starnet is a powerful tool to help you separate the stars from the nebula or galaxy behind them. Load your stacked and stretched image. Starnet only supports 16-bit TIFF files. Change the name of the final image, and now press Run, and Starnet will generate a starless image. This Starnet tool is really useful when we are processing Milky Way pictures, so the Milky Way will pop more and we can edit them separately. Open the starless image and the picture with the stars in Photoshop. Put both pictures as layers. Duplicate them and apply the blending mode difference. Now merge both layers. You will get a layer with the stars separated, that you can later blend with different blending modes. Now you can process the background, Milky Way, nebula, dust, galaxies, separately from the stars. You can boost contrast, colors, or details without bloating the stars, and recombine the stars later for a clean, controlled result. You also have noise reduction option in Photoshop. Go into Filter, Noise, and Reduce Noise. In Photoshop you can also open Camera Raw, pressing Ctrl-Shift-A on your keyboard, with the layer that you want to edit selected. It's like Lightroom. One trick to boost the texture in your nebula or Milky Way pictures. Duplicate the layer, it's better if it's without stars. Change the blending mode to Overlay. Then, go to Filters, Other, and High Pass. Adjust manually the slider, between 90 and 300. You will see what's the best. You can also include foreground or terrain in your astrophotos. The best is that you take the pictures in the blue hour, after sunset or before sunrise. You need to take them with the same focal distance, framing, and location as the night sky pictures. When editing, open them in Photoshop as layers. Cut the sky of your foreground pictures and merge it with the night sky picture behind. So, this was all for the tutorial of today. Feel free to leave your questions in the comments, and you can also share your results. Thanks for watching, I hope you have learned a lot about astrophotography, and I hope you clear skies.